Alright, your volume test tomorrow, here's your review. What's going to happen is we're going to have one function, one region here that we're going to rotate amongst a bunch of different areas, a bunch of different axes of revolution. The first one here is the x-axis, so we're looking at something like this for this region that's shaded in yellow. If it's around the x-axis, that means we need a function in terms of x, which we do here. So that means my volume will equal, it's pi times the integral, we'll talk about the limits in a minute, of whatever the function is, squared, dx. It's in terms of x, which is what we want. Now the limits. The limit should be, well, where's the intercept? Well, this is where it's bounded between y equals 0, which is this, and x equals 2, which is this up and down line. What are my x values here? Well, I can even look at this. If y equals 0, what would x have to be? It would have to be 0. And my upper limit is when x is 2, which we already wanted. So from 0 to 2. So that means that I can now, first let's expand this. 2x squared, all of it squared. I spread that in there, I distribute it in and get 4x to the 4th power dx. Okay, this means when I now evaluate this integral, I still have the pi out in front. 4x to the 4th will now become 4/5 x to the 5th. I need that evaluated at 0 and at 2. Well, when I plug in 2, 2 to the 5th is 32. 32 times 4, excuse me, would give me 128 over 5. And if I plug in 0, it's just 0. So when I subtract those, it's just 128 over 5. So that's multiplied by pi. So my final answer is 128 pi divided by 5. 128 pi over 5 as my answer. All right, number 2. It's the exact same function, the exact same region, except now we're going to revolve it around the y-axis instead of the x-axis. So what that means is I need to take this function and I need to turn it in terms of y. I need to get x by itself. So I'll first divide both sides by 2, and then I'll take the square root of both sides. That way now I have x by itself. Now here's the other thing. I need limits that are in terms of y. So again, volume equals pi times the integral of, I'm going to have this new function, the square root of y over 2 squared dy, but what are my limits? Again, in our picture, we have something that looks like this. We have a function right here that went up to 8 and 0. So that could tell you something right there, but even if you didn't have the picture, you could say, well, y equals 0, that's my lower limit, that's perfect. When x equals 2, if I plug that in, I could find what y would have to be, which is 8, because 2 times 2 squared is 8. Okay, we'll now simplify it. Still pi in front, integral from 0 to 8. The square root of something squared is just what's on the inside, y over 2 dy. I'm even going to take this 2 on the bottom, and I'm just going to pull it out, because it's a constant. It doesn't have to go anywhere, so I'm just going to leave it as 1/2 pi, or as pi over 2, and I'm going to have just y dy inside my integrand. Now let's actually take and evaluate the integral. Pi over 2 is still out front. The integral of y is 1/2 y squared from 0 to 8. When I plug in 8, I'm going to have 8 squared, which is 64, divided by 2 is 32. And if I plug in 0, I'm going to get 0. So I should have pi over 2 in front times I have 32 on the inside. So 32 divided by 2 is 16 times pi. My answer is 16 pi. All right, for number 3, we're now revolving not around one of the axes, but this time around the line y equals 8. Well, y equals 8 is a horizontal line. So again, if here's your graph, it looks like we have something that looks like this, intersecting at 2 and 8, kind of the point that we wanted. We still have this region here that I'll draw in yellow. What's happening here is this line right here, we're revolving around, we need it to essentially become the x-axis. How can I do that? By just shifting everything down 8 units. So all I'm going to do is take my function and just subtract 8 from it. Everything else will stay the exact same as it was in number 1 because we have a horizontal axis of revolution. So pi times, it's still from 0 to 2. My new function is 2x squared minus 8, that whole thing squared, dx. Here's the biggest issue that we're going to have. If you mess something up, it'll probably be this. And it's just simple FOILing. This is 2x squared minus 8 times 2x squared minus 8. So that means it'll be 4x to the fourth. I'm going to have minus 16x squared minus another 16x squared to give me minus 32x squared, and then plus 64 on the end, dx. I'll now evaluate this integral, take the antiderivative, and I should have 4/5 x to the fifth. I'm going to have 32 over 3 x cubed. I'm going to have 64x, and this is being evaluated from 0 to 2. So I'm going to plug in 2, I'm going to plug in 0, and I'm going to subtract them. When I plug in 2, I should get 1024 over 15, and when I plug in 0, I get 0. So that subtraction is just a 1024 over 18, so my answer is 1024 pi over 15 for my final answer. All right, number 4. This is one where we said don't worry about solving it, just set it up. We're going to first say, well, the line x equals 2, that was that vertical line over here. So that means because it's a vertical axis, I need to get it in terms of y. And we said that I got that x equaled the square root of y over 2. That's what we get in number 2. So the same thing here, if I have my graph that looks something like this, and I want to rotate it around this line right here, what do I need to do to get it so that it is on the x-axis? Well, here's the way you should look at it. Whenever we have a shape like this, where we're doing it in terms of y, really you should kind of look at it in this direction, like you've rotated it around. And then you should ask yourself, how do I get it to be on that axis? And you should say, well, from this angle, you bring it down 2 units. Really, you're bringing it, when you look at it the right way, you're bringing it to the right 2 units, but we need to talk about it in terms of y. So we are going to bring it down 2 units, so we will subtract by 2. So all you would do here is volume equals pi times. We said our limits were 0 and 8 in number 2. That's what we wanted. And then our function is the square root of y over 2 minus 2, that whole thing squared, dy. You can go ahead and try to solve that if you want, but we're going to stick right there as our answer. All we wanted to do was just set up number 4. All right, numbers 5 and 6. We have now the region between 2 different solids. So this is what we need to look at. First, let's get a good picture of it up here, or just a rough sketch, I should say. We have one function that looks like this. We have another function that comes kind of through like that. This is my x squared function. The one on top is the 4x minus x squared function. So first, what we need to look at is where do these points intersect? If I don't have a graph, I can still figure it out. I'm just going to set them equal to each other. X squared equals 4x minus x squared. Add x squared to both sides, I'll get 2x squared, and I'll subtract 4x to get it on the same side, equals 0. Pull out a 2x, I'm left with x minus 2. So that means my intersection points are x equals 0 and 2. That means those are my intersection points. Volume equals pi times the integral from 0 to 2. Now, how do I know that 4x minus x squared is the one that's on top, especially if I don't have a picture to go by? Well, let's plug in 1 for both equations. So here's the first equation, here's the second equation. For the first equation, what is f of 1? It would be 1 squared, which is 1. For the second one, f of 1 is 4 times 1 minus 1 squared, which is 3. So which one's on top? This guy out here, the 4 minus x squared. So that's what I need to put first. 4x minus x squared. That one gets squared. And now I'm going to subtract the other one. Subtracting x squared quantity squared dx. Now let's simplify this out. Pi times from 0 to 2. This will be 16x squared. I'm going to have a minus 8x cubed. And I'm going to have a plus x to the fourth. And then with this one, I'll have a minus x to the fourth dx as my final point there. Now look, x to the fourth and x to the fourth, they'll cancel each other out. Now we can just evaluate our integral nice and easy. Pi times, when I take the antiderivative, 16 over 3 x cubed minus, this will become 2x to the fourth. And then I need to evaluate this from 0 to 2. From 0 to 2. When I plug in 2, I should get, should be 16 times 8 all over 3. So that should be 128 over 3. And then when I plug in 2 here, it'll be 16 times 2, which is 32. So when I subtract that, I should get as an answer here, it should be 32 over 3. When I plug in 0, I get 0 minus 0, which is just 0. So I'll subtract these two answers. My final answer is 32 over 3, and don't forget your pi. So 32 pi over 3 as your final answer. Now, for the last one, this should be very similar to what we did in numbers 3 and 4, and all we're doing is to set it up. So we have the same equation, we have the same two shapes here, and we now want to revolve around this line up here of x equals 6. So it is a horizontal line, so we still want to keep everything in terms of x, which is good. Again, how do I get this line so that it's on that horizontal axis? Well, I got to bring everything down by 6 units. So that means now my equation is pi times same limits that were from 0 to 2 we said, and our functions now, because we brought everything down 6, I need to subtract both by 6. So I'll have x squared minus 6 squared. Actually, I said that backwards because that's the one that we said was on the bottom. So what I need to do here is this should be my second function. My first function, the one on top, is going to be the 4x minus x squared minus 6, that quantity squared. Subtract them, dx. There is your final answer. Again, we just want to set it up. We could go and expand and try to simplify, but all we're going to worry about for this one is just setting it up properly. There you have it, volumes, and we're finishing up everything we need for AP Calc.